Hello everyone, welcome to Math Mindset. In this video, I'm gonna do last year Applied Mathematics 1B final exam. As you see here, the first part said write true for the correct statement and false for the incorrect statement in the designated space. Number 1, norm of u square is equal to u dot u. We have this property. Now we need to use this property for the first question. We need to apply it for u plus v and u minus v. So norm of u plus v square means u plus v dot u plus v. So dot product distribute over addition. From that we will have u dot u plus 2 times u dot v plus v dot v. U dot u, here we have u dot u, that's magnitude of u square, therefore this is magnitude of u square, plus 2 times u dot v plus v dot v, magnitude of v square. So the given for two non-zero orthogonal, whenever u orthogonal to v, this implies u dot v is equal to 0. Therefore, this value is 0. Then norm of u square plus norm of v square. And also, norm of u minus v square is equal to, apply this property again, u minus v dot u minus v. Dot product distribute over addition. U dot u minus u dot v minus v dot u. Dot product is commutative, 2 times u dot v plus minus v dot minus v plus v dot v. Again, u dot u means magnitude of u square minus 2 times u dot v plus v dot v, magnitude of v square. But we know that they are orthogonal, therefore the dot product is 0. This becomes magnitude of u square plus magnitude of v square. So these two values are equal. Magnitude of u plus v square is equal to magnitude of u minus v square. So take the square root both sides. This implies magnitude of u plus v is equal to magnitude of u minus v. So the answer is true. Question number 2. If A and B are invertible n by n matrix, then adjoint of AB is equal to adjoint of A times adjoint of B. Now, first remember the property what we have. AB, invertible matrix A and B, inverse. From inverse property, we know that this is the same as B inverse A inverse. When we apply adjoint method for AB inverse is equal to 1 over determinant of AB times adjoint of AB is equal to 1 over what's determinant of AB, property of determinant of A times determinant of B times adjoint of AB. And in the other way, what's B inverse? 1 over determinant of B times adjoint of B. Similarly, A inverse, 1 over determinant of A times adjoint of A. These two are equal. This implies 1 over determinant of A, determinant of B, adjoint of AB, that's AB inverse, is equal to B inverse A inverse, 1 over determinant of B times adjoint of B times A inverse 1 over determinant of A times adjoint of A. Now multiply both sides by determinant of B and determinant of A. This gives us adjoint of AB is equal to adjoint of B times adjoint of A. Now look, adjoint of B times adjoint of A. Now, as you know, product of matrix is not commutative. This is different from adjoint of A, adjoint of B. Therefore, our answer is false because the statement said that adjoint of AB is equal to adjoint of A times adjoint of B. Question number 3. If limit of g of x as x approaches to c exists and f is a function that is equal to g for all x sufficiently close to c, except possibly at c itself, then limit of g of x as x approaches to c is equal to limit of f of x as x approaches to c. Now the answer here, it is true, because always remember, whenever we discuss about limits, we are considering for value of x near to c. So if f and g are equal near to c, their limit is equal. For all x near to c, look, the two functions f and g are equal for all x sufficiently close to c. So limit of g of x as x approaches to c means the value of g near to c sufficiently close to c. Similarly, limit of f of x as x approaches to c means the functional value of f sufficiently close to c for x. So they are equal already, we said here. Therefore, it is a true statement. Question number 4. The mean value theorem can be applied to the function f of x is equal to 1 over x on the interval -1, 1. Now remember the theorem. The theorem says that to apply the mean value theorem, first the function f should be continuous on the closed interval and it should be differentiable on the open interval. But as we see here, the function f of x 1 over x at x is equal to 0, the function is not continuous, but 0 is between the interval -1, 1. So the mean value theorem cannot be applied here. Your answer should be false. Question number 5. The improper integral from 0 to 4, 1 over square root of 4 minus x dx. Look, you are asked to evaluate the integral from 0 up to 4, 1 over square root of 4 minus x dx. Obviously, this function, the integrand, is unbounded at 4. Therefore, we have the improper integral. This is the limit of from the improper integral. We know that this can be written as from 0 up to t, 1 over square root of 4 minus x dx, as t goes to 4 from the left. We need to use here integration by substitution. Let u be 4 minus x. Then du by dx is equal to the derivative of this function -1. From this, we obtained dx minus du. So the integral, the indefinite integral of 1 over square root of 4 minus x dx is equal to the integral of 1 over square root of u, what's du minus, what's dx minus du. So this is minus the integral of square root of u, 1 over square root of u, u the power of -1 over 2 du. This is equal to minus u the power of -1 over 2 plus 1 over -1 over 2 plus 1. This is equal to -1 over 2 plus 1, it is 1 over 2. So here we have 1 over 2 reciprocal minus 2 u the power of 1 over 2 What's u? U 4 minus x. So minus 2 in bracket 4 minus x, the power of 1 over 2. So now the integral of 0 to 4, 1 over square root of 4 minus x dx is equal to limit of the indefinite integral from 0 up to 2 minus 2 4 minus x the power of 1 over 2 from 0 up to t as t goes to 4 from the left is equal to limit as t approach to 4 from the left. Substitute t for x minus 2 4 minus t raised to 1 over 2 minus substitute 0 minus 2 4 raised to 4 minus 0 raised to 1 over 2 is equal to limit of, look, minus 2 times 4 minus t the power of 1 over 2 minus minus plus 2 times radical for 2, that is 4, as t goes to 4 from the left. Now when you substitute t by 4, it becomes 0. So the result will be 4. The limit exists. That means convergent. Here is part 2. Select the correct answer from the given choice. Question number 1. Which of the following statement is not true about the base of a vector space V? Remember, the subset of V to be a base for the vector space, we need to have linearly independent and B should generate V. These two are the main conditions to say that the given set B is basis. So they are true. And we know the dimension of the vector space means the number of elements, the base, the cardinality of this is the cardinality of elements of B, the cardinality of set B, the number of elements in the set, in the base. That's the dimension of V. So B, C, D are true. Linearly dependent could not be a basis for the vector space. So B could not be linearly dependent. Not true. Yes, the answer is A. Question number 2. The vector whose length is 3. You have vector u, let's assume. Vector u, the length is 3. So assume u is equal to magnitude of u is equal to 3. So what's vector u? Vector u is 3 times a unit vector. Small u, this is a unit vector. So vector u is the same, has the same direction as vector v, means the unit in the direction of v we have a unit vector. So the unit vector u will be obtained from v. So this will be 3 times v over magnitude of v. So first we need to evaluate magnitude of v. What's magnitude of v from this? Magnitude of v is equal to the square root of 6 square, 36, plus 3 square minus 3 square, 9. That is square root of 45. 9 times 5. 9 means 3. Square root of 5. 3 square root of 5. So this is equal to 3v over 3 square root of 5. 3 cancels 3. What remains? V over square root of 5. So our choice here, the answer is B, 1 over square root of 5.
Question number 3. Limit of cubed root of x plus 1 minus 1 over x as x approach to 0. Evaluate the limit. Here we need to check that the limit of the numerator and the limit of the denominator separately first to apply quotient rule. What will be the result? So limit of cubed root of x plus 1 minus 1 as x approach to 0. It is a continuous function, so we substitute x by 0. Therefore, cube root of 0 plus 1. Cube root of 1 is 1. 1 minus 1, that is 0. The denominator is obviously 0. Therefore, we have 0 over 0 indeterminate form. What we need to do here is to apply L'Hopital's rule. The limit of cube root of x plus 1 minus 1 over x as x approach to 0 is equal to L'Hopital's rule. Derivate the numerator and the denominator. The limit of the derivative of this function, look, the difference, minus 1, derivative of 1, 0. This one means x plus 1 raised to 1 over 3 cubed root. Its derivative over the derivative of denominator, that's 1, as x approach to 0 is equal to, from the derivative rule we know that this is limit as x tends to 0, 1 over 3 x plus 1 the power of 1 over 3 minus 1, that is negative 2 over 3. But as x goes to 0, the inner function goes to 1. 1 the power of n number is 1. So the result will be 1 over 3. Therefore, our answer is C. Question number 4. The values of a and b for which the function f of x squared plus b for x less than or equal to 1 and 1 over x for x greater than 1 is differentiable at 1 at the number where the function splits. Whenever the function is differentiable, it is continuous. So we know here the function is continuous. Now we need to apply the property of continuity of function because every differentiable function is continuous. So the function is continuous at 1. Now let's see. F of x is given by, and it is differentiable at 1. So the function is differentiable at 1. F is differentiable at 1 implies f is continuous at 1. Therefore, we have to check the limit of f of x as x approach to 1 is equal to f of 1. We have this. But look, the limit at 1, but the function is split at 1. Therefore, we have to find the limit from one direction, one-sided limit. Limit of f of x as x approach to 1 from the right. Whenever x approach to 1 from the right, x is greater than 1. When x is greater than 1, the function f of x is 1 over x. Therefore, this is limit of 1 over x as x tends to 1 from the right. So the limit, quotient rule, 1 over 1, that is 1. And from the left, limit of the function f of x as x approach to 1 from the left, x less than 1. So if x is less than 1, the function is x squared plus b. So limit here, f of x is x squared plus b as x tends to 1 from the left. Polynomial function is limit a plus b. So the limit exists means left and right sided limits are equal. Therefore, a plus b is equal to 1. The functional value is also equal, that's f of 1 a plus b. Now we have only this result. So what we need to check is from the choice the sum of a and b that give us 1 is our answer. Now here let's check. Choice A, 3 over 2 plus 1 over 2, different from 1. B, minus 1 over 2 plus 3 over 2, that is 1. The answer is B. Minus 3 over 2 plus 1 over 2 different from 1. 1 over 2 plus 3 over 2 different from 1. Question number 5. F of A is given by this limit for any A. Now then you are asked to find f of 4. Look, what's f of A? This is f of A, what we have given. Now find f of 4. So when A is 4, limit of x to the power of 4 minus 4x squared plus 4 minus 1 over x squared minus 1 as x tends to 1. Now evaluate these limits. First, try always the quotient rule. If we apply the quotient rule, the numerator 1 minus 4 plus 4 minus 1, 0. So this is 0 over 0 form, indeterminate form. So we can apply L'Hopital's rule. Therefore, this is equal to limit of the derivative of the numerator 4x cubed minus 8x over x squared minus 1 to x as x tends to 1. Now apply the quotient rule here. That is 4 minus 8 over 2. We have minus 4 over 2, that's minus 2. So the answer is D. Question number 6. The equation of the tangent line to the curve x cubed plus y cubed is equal to 2xy at the point. Look, you have the curve equation and one point on the curve where the tangent line touch. So find equation of the tangent line. Always to find equation of the tangent line, we need to have one point. Already we have one point. What remains? The slope. So what's the slope of the line? That's dy by dx at the point 1, 1. This is our slope. So we have the slope, we have the point means we can get equation of the line. Now let's see. Equation of the curve. X cubed plus y cubed is equal to 2xy. Now first find dy by dx. Derivate both sides with respect to x. D by dx of x cubed plus y cubed is equal to d by dx of 2xy. Now apply addition rule. So d by dx of x cubed 3x squared plus y cubed but dx. So chain rule. D by dy of y cubed, that is 3y squared times dy by dx, the chain rule, is equal to, here apply product rule, to x one function, y the other function. So derivative of 2x, that is 2 times y, plus derivative of y times 2x. So 2x dy by dx. Then collect like terms here. Subtract both sides this value and take dy by dx common. You will get 3y squared minus 2x dy by dx is equal to 2y minus 3x squared. Then from this dy by dx is equal to 2y minus 3x squared over 3y squared minus 2x. Our target is the slope at the point 1, 1. So this implies dy by dx at the point 1, 1 is equal to, substitute for x and y, 1, 1. That's 2 minus 3 over 3 minus 2. That's -1. The slope is -1. Now to determine equation of a line, always y minus the y component 1 over x minus the x component in the point 1 is equal to the slope. So multiply both sides by x minus 1. Y minus 1 is equal to minus x plus 1. Add both sides 1. Y is equal to minus x plus 2. Or we can add both sides x and we have y plus x is equal to 2. That's the equation of the line, the tangent line. So our answer is choice B. Question number 7. The nth derivative of y is equal to 1 over x. Y is equal to 1 over x. Now find the formula for the nth derivative. So dy by dx, or let's use y prime instead to see the number, no problem. The derivative of 1 over x. 1 over x means x to the power of minus 1. So apply continuously the rule x to the power of n derivative. That's n times x to the power of n minus 1. So here we have minus 1, n is minus 1, minus x to the power of minus 1 minus 2. Then the second order derivative, minus to n, minus plus 2, x to the power of minus 2 minus 1 minus 3. Then the third order derivative, n is minus 3, so minus 3 times 2, x to the power of minus 3 minus 1 minus 4. The fourth order derivative, that's minus plus 4 times 3 times 2, x to the power of -5. Now from this we have to observe, we can observe from this that what is the nth derivative. Look, whenever n is 1 it's negative, n is 2 positive, n is 3 negative, n is 4 positive, so minus 1 raised to n. When n is odd, negative, when n is even, positive. Times, when it is 1, 1, when it is 2, 2, when it is 3, 3 times 2, when it is 4, 4 times 3 times 2. That means when it is n, it will be n factorial. Times x to the power of, look, when 1, -2, 2, -3, 3, -4. So when it is n, that is negative of n plus 1. Or we can write this minus 1 raised to n, n factorial over x to the power of n plus 1 from the exponent rule. This is our answer. So here we have n factorial minus 1, not here. The answer is B. Question number 8. If f of a is 2, f prime at a is 2, g prime at a 2, g of a minus 1. Then the value of this one. Let's see. Look what we have. Evaluate this one. But what do you know? We know f prime at a means limit of f of x minus f of a over x minus a as x approach to a, and g prime at a limit of g of x minus g of a over x minus a as x approach to a. We have here f prime at a2 and g prime at a2. So here we have g of x f of a, g of a f of x. Always whenever you have such mixed, but you need to separate, always think about adding some expression. Here for this problem we need to add, look, first let's see, g of x f of a. Consider only the numerator minus g of a f of x. If we add here f of a, g of a, and subtract again f of a, g of a. Now g of x minus g of a, we have common f of a, f of a. So this is equal to f of a in bracket g of x minus g of a, plus here we have minus g of a is common. So if you take minus g of a as a common factor here for these two terms, what remains? F of x minus f of a. Now we have this. So over x minus a. So totally this expression can be written as limit of, now we can replace this by f of a, g of x minus g of a over x minus a minus the other here, g of a in bracket f of x minus f of a over x minus a, common denominator as x goes to a. Now apply the limit rule. So when you apply all the limit rule here, our result, this result becomes f of a times g prime at a minus g of a times f prime at a. What's f of a? 2. G prime at a, 2, 4, minus g of a, negative 1, times f prime at a, 2. So the answer becomes 6. So our answer is C. Question number 9. A polynomial function f of x on the interval minus 5, 2. Then absolute maximum value. Simply, polynomial function always differentiable, everywhere differentiable. So the critical numbers, to get absolute maximum minimum, first we need to find the critical number. So what's f derivative at x? The derivative of the polynomial function, 3x squared plus 6x minus 9. Then the critical numbers means this value being 0. So divide both sides by 3. X squared plus 2x minus 3 is equal to 0. So factorize this one. X plus 3, x minus 1 is equal to 0. The product to be 0, one of the two should be 0. So x is equal to minus 3 and x is equal to 1. Now we have two critical numbers and you have to check whether they belong to the interval or not. Both belong to the interval. Therefore, you have to find the functional value for each critical number. F of minus 3, find this, f of 1, and the boundaries, the end point of the interval, f of minus 5 and f of 2. Now from this, the maximum value is the absolute maximum. So I left this for you to complete it. The last multiple choice, question number 10. The area of the region bounded by the graph of y is equal to sine x and y is equal to cos x between 0 and pi over 4. We have two functions, y is equal to sine x and y is equal to cos x. On the interval 0, pi over 4. First we need to sketch, a rough sketch, the graph of sine function. This is sine. And the graph of cosine function. Cos x. To get the intersection point, Sine x is equal to cos x. Divide both sides by cos. Sine x over cos x. Sine x over cos x is equal to 1. Tan x is 1. So what's x? Tan inverse of 1. That is pi over 4. This intersection point is pi over 4. So the region is this one. Now, area of the region is the integral from 0 to pi over 4 cos x minus sin x dx. The integral of cos x sin x minus sin x, that's cos x, from 0 to pi over 4. Now look, sine pi over 4 root 2 over 2 plus cos over 4 root 2 over 2 minus sine 0 0 plus cos 0 1. So the result becomes root over 2 plus root over 2 root 2 minus 1. This is our answer. So the answer is choice B.
The short answer part. In the first problem, you have given norm of V, norm of V dot W, and norm of W. Then find the value of norm of W minus 3V square. Now remember what we have seen before. Norm of U square means U dot U. So apply this property for this one. Therefore, norm of W minus 3V square means W minus 3V dot W minus 3V. Distribute dot products. W dot W minus 2 times minus 3V minus 3V. I mean minus 3V dot W minus 3V dot W minus 6V dot W plus negative negative 339 V dot V is equal to magnitude of W square U dot W dot W means minus 6 times V dot W plus 9 times magnitude of V square. What's magnitude of W? It is 2. 2 square 4 minus 6 times V dot W 4 24 plus 9 times norm of V square 9 81. So 4 minus 24 minus 20 plus 81 61. That's the answer for question number 1. Question number 2. Let A be a square matrix of size 4 such that determinant of A inverse is 4. Then what's determinant of A inverse? If you remember the formula, that's very simple. One is the reciprocal of the other. Therefore, it is 1 over 4. That's the answer. But if you don't remember, always remember this property. A dot A inverse is identity matrix. So from this, the determinant of A inverse is equal to determinant of the identity matrix, that is 1. And from determinant property, we know that this is determinant of A times determinant of A inverse, that is 1. So 1 is the reciprocal of the other. From this, we got that determinant of A is equal to 1 over determinant of A inverse, and vice versa. Determinant of A inverse is 1 over determinant of A. Therefore, the answer is 1 over 4. Question number 3. Limit of 1 minus cos x over x as x goes to 0 from the right. This is one of the important limit what you have in the discussion. Therefore, immediately you have to remember the answer is 0. But if not, simply look, direct substitution, check. What's the limit of 1 minus cos x? When x is 0, cos 0 is 1. 1 minus 1. This is 1. 1 minus 1, that's 0. What's the limit of x as x goes to 0? 0. Therefore, 0 over 0. Indeterminate form. So apply L'Hopital's rule. Therefore, this limit will be equal to the limit of, look, the derivative of the numerator, minus minus plus sine x, over derivative of x is 1 as x goes to 0 from the right side. So the limit of sine x as x goes to 0, continuous function, the limit, direct substitution, sine 0. Sine 0 is 0. That's the answer. Number 4, find the critical numbers, number or numbers, one or more, for the function f of x. So this is polynomial function. We have only critical numbers that makes the derivative 0. First, find f prime at x. F prime at x. Here, 2x cubed is derivative 6x squared, minus here minus 3x squared, 6x. Here minus 12x minus 12. So the derivative is 0. Implies divide both sides by 6. X squared minus x minus 2 is equal to 0. Now look, the product -2, the sum -1, -2 and 1. Therefore, this implies x minus 2, x plus 1 is equal to 0. So the product to be 0, one of the two should be 0. Therefore, either x is equal to 2 or x is equal to -1. So we have two critical numbers, 2 and -1. Question number 5. The function y is given by radical tan of 2x. The composition of three functions, radical of x, tan of 2x, tan of x, and 2x. So dy by dx, apply chain rule, is equal to, look, the derivative of radical x is 1 over 2 times radical of x. But what's the inner function? Tan 2x. So tan 2x times the inner function tan x derivative sec square x, but in place of x we have 2x times the inner function 2x derivative, that is 2. So 2 cancel 2, then the result will be sec square 2x over radical of tan of 2x. That's the answer. Question number 6. Find the length of the curve y is equal to x the power of 3 over 2 from 2 up to 4. Let's do it here. Remember, the length of the arc on the interval a to b is a to b, the square root of 1 plus f prime at x square dx. Now, what's f prime at x square? What's f of x? F of x is, that is y, x the power of 3 over 2. Then f prime at x, the derivative, 3 over 2, x the power of 3 over 2 minus 1, 1 over 2. So f prime at x square is equal to 9 over 4 x. Therefore, the length of the arc length is the integral from a is 2, b is 4, the square root of 1 plus 9 over 4 x dx. Now, let's use integration by substitution. Let's u be, first let's find the definite integral, the indefinite integral. Let u be 1 plus 9 over 4x. This implies du by dx is equal to 9 over 4. So dx is equal to 4 over 9 du. Now the integral of square root of, look, this one is u times what's dx, 4 over 9 du. So the integral of radical u the power of 1 over 2. So u the power of 1 over 2 du, the integral. That's u the power of 1 over 2 plus 1 over 1 over 2 plus 1. That is 3 over 2 to over 3, u the power of 3 over 2. What's u? 1 plus 9 over 4x. So the result becomes 2 over, here we have 4 over 9, 2 over 3 times 4 over 9 times u, 1 plus 9 over 4 x the power of 3 over 2. This is the integral. Now the indefinite integral from 2 up to 4. You make it from 2 up to 4. So you can write this as, that's 8 over 27, and then substitute 4 minus substitute 2 and simplify, and you'll get the answer. Now this is from part 1 up to part 3. What remains from the final exam, from last year final exam, that's the workout problem. So in the next video I will do the remaining workout part of the last year exam. And to get that video, it's better to subscribe the channel and click the notification button. You'll get the video immediately as I release. Thank you for watching.